as promised, this video is going to talk about the scientific method. I'm going to show you step by step what scientists go through when actually trying to do science, and kind of show you the rigor and intensity with which science is conducted. So first, it all starts with observation and curiosity. Scientists will maybe read something in other published papers. Maybe they'll observe something about the universe, see something weird or unique in some other research they're doing, and they think more about that. They think, why is that, or what could this be? And from there, they form a hypothesis. So a hypothesis is the closest thing to a guess in science. Now, it's an extremely highly educated guess, because a hypothesis will take any current evidence or data one might have, along with the observations that they've already performed, and any literature they have already, plus their existing knowledge base, to make the most educated guess possible, right? So basically, a hypothesis is a scientist saying, I think that this is the result of this observation I saw, and here's why. So from there, they have to design and conduct experiments. And after performing these experiments, you have to collect the data, look at the evidence, and make more observations. If those observations are inconsistent with, I just realized I spelled that wrong, my bad. If they are inconsistent with the hypothesis, you have to circle back to the hypothesis and redevelop it. Now, that's another thing I want to mention, is that sometimes people will try to poke holes into scientific theories and ideas, and because some people are under the impression that if one aspect of a scientific concept is proven incorrect, then the entire thing is invalid, and that's just not how science works. Because it's very, very possible for something to be partially correct. So if you get something that's not fully supporting what what you think is the result, well, maybe you're partially correct, right? So go back and reform it. You don't have to scrap it entirely, but maybe you have to alter a few things about it. So if you have your initial experiments are inconsistent with your hypothesis, go back and reform your hypothesis. And you'll have to keep doing that over and over until you finally get consistent results, that repeatable, consistent results. So if they are consistent, then you have to ask yourself, does that contribute to the existing body of knowledge? So what does that mean? Basically, does it actually provide significant insight into some kind of scientific concept? Is it interesting? Is it novel? So is it unique? Can it be used to help further science? If it can't, well, then you once again have to recycle all the way back to your hypothesis and reform it into a way that it is significant to the body of science and that it can contribute. If it can, though, now you could have a publishable study. It's possible you may have to do even more experimentation to prove it, but you could have a publishable study at this point. Now, if that study is then further supported by many, many other studies, by an absolute ton of data over many more years of research by many other scientists, in fact, it can contribute to the development of a theory, or potentially itself become a theory. But again, that's only after all of these questions are asked, and it's a thoroughly vetted process. You have to make through many difficult, peer-reviewed publications, and as someone who has gone through publishing myself, I can tell you that it's not exactly an easy thing. And also, if your study helps reveal a constant observation about the universe, it could potentially become a law, or at least contribute to the development of a law. So this is just a general look at the scientific method. Shows you all the many steps that scientists have to take and the rigor of it, and why it can be so intense to conduct, and potentially sometimes slow-moving to conduct good, legitimate scientific research.